Good afternoon, everyone. In today's class, we are going to start the unit 2nd, and the name of the topic is virtualization. First is virtualization in cloud computing. Now we will study what is virtualization in cloud computing and how can we achieve virtualization in cloud computing. So virtualization is the creation of virtual, which means rather than actual, which is not physically present. So virtualization is the creation of virtual version of something. Virtual means that exists but not physically, such as server, desktop, storage devices, and operating system or network resources. It means we are achieving virtualization in the cloud computing. Virtualization means the thing that does not exist in the physical manner. So virtualization means we have to create virtual versions of, we can create virtually a server, we can create virtually a desktop, or we can create virtually a storage device, operating system, or network resources. Virtually means the thing is existing but not physically present. It's completely virtual. In other words, virtualization is a technique which allows to share a single physical instance of resources or an application among multiple customers and organizations. If we are implementing the concept of virtualization, we don't need to put more cost on purchasing multiple applications for multiple customers. We can even share a single physical instance of resources among multiple customers and multiple organizations. It does by assigning a logical name to the physical storage and providing a pointer to that physical resources when demanded. So how can we achieve virtualization? We just need to give a name. We just need to assign a logical name to the physical storage, and we simply need to point to the physical resources when they are requested and when they are demanded. So virtualization in cloud computing means we have to do virtually. We have to establish the server virtually, desktop virtually, storage device virtually, operating system, network resources, everything is virtually. They all are working, but still they are not visible. So this is called virtualization. What is the concept behind the virtualization? Creation of virtual machine over existing operating system and hardware is known as hardware virtualization. So if we are creating, now we are working with a virtualization, so we have to work on the VM, that is called virtual machines. For achieving the virtualization in cloud computing, we just need to move forward for virtual machines. So when we create a virtual machines over the existing old operating system, so when we are creating virtual machines over the existing operating systems, over the existing hardware, this is called hardware virtualization. Virtual machine provide an environment that is logically separated from physical hardware. So virtualization is another concept. It is not equivalent to the physical working of server, desktop, and anything else. The machine on which the virtual machine is going to create is known as host machine, and the virtual machine is referred to as a guest machine. So we have two types of machine. One is host machine, and second is guest machine. So the machine on which we are creating a virtual machine is called a host machine, and one of the virtual machine that we have created is called a guest machine. So virtualization means what we need to do, we are working on a server, we are working on a desktop, we have operating system, we have a network resources, but they all are not visible. So for achieving the virtualization, we have two types of machines. One is host machine and second is guest machine. Virtual machine is called a guest machine, and the machine on which we are developing the virtual machine is known as host machine. Next, types of virtualization. How many types of virtualization we have in a cloud computing? We have hardware virtualization, operating system virtualization, server virtualization, and storage virtualization. Now, first we are going to discuss about hardware virtualization. It means how can we achieve hardware virtualization in cloud computing? When the virtual machine software or virtual machine manager, that is known as VMM, is directly installed on the hardware system. It is known as a hardware virtualization. Now we are going to achieve a hardware virtualization. It means we have to add up or we have to import the virtual machine directly on the hardware. That's why in this way we can achieve a hardware virtualization. The main job of hypervisor is to control and monitoring the processors, controlling the memory, and controlling the hardware resources. We have one term in virtualization that is called hypervisor. The task or the job of hypervisor is to control the working, the monitoring of processor, controlling the performance of memory, and controlling the other hardware resources. After virtualization of hardware system, we can install different operating system on it and run different applications on those operating system. So hardware virtualization means we are installing, we are importing, we are embedding the virtual machine directly on hardware. So this is called hardware virtualization, and we know that we have a one term that is called hypervisor. Basically, hypervisor is responsible for controlling and monitoring the processors, memories, and other hardware resources. Once the virtualization is done, once you achieve the hardware virtualization, you can install different operating system and you can run different applications on those operating systems. We are free to install any type of application. We are free to install any type of operating system. Next, we have the uses of hardware virtualization. Hardware virtualization is mainly done for our server platforms because controlling virtual machine is much easier than controlling a physical server. Basically, why we go for a hardware virtualization? The reason is that it's very easier to control the virtual machines, but sometimes it take a more time and sometimes it's tough to control the physical servers. That's why we need to go for a hardware virtualization. So hardware virtualization means we are importing, we are embedding the virtual machines directly on the hardware system. Once we have done with the hardware virtualization, we can install different types of operating system on it. We can run a different types of applications on these operating systems. Next is that we have one hypervisor that is responsible for to control how the processor is working, how the memory is working, how the other hardware resources are working. All these controlled and managed by hypervisor. So uses is that sometimes it's very easier to handle virtual machine rather than handling the physical servers. Next, we have operating system virtualization. When the virtual machine software or virtual machine manager, that is called VMM, is installed on the host operating system. Now this is not, we are not installing the virtual machine manager or virtual machine softwares on the hardware. In this type of virtualization, we are installing the virtual machine manager on a host operating system. That's why this is called operating system virtualization. Its uses are operating system virtualization is basically used when we want to test the applications on the different platforms of operating system. It is basically used when we want to test different applications on different operating systems. That's why we need to do the operating system virtualization. So operating system virtualization means we are installing the virtual machine manager, that is called VMM, on the operating system, not on the hardware. That's why it is called operating system virtualization. And we go for operating system virtualization when we want to test multiple applications on the different type of operating systems. Next, we have a server virtualization. This is the third type of virtualization. In this case, virtual machine softwares or a virtual machine manager, that is called VMM, is now directly installed on the server system, not installed on a computer hardware, not installed on a host operating system. Now we are installing directly it on the server system. That's why this is called server virtualization. Its uses is that server virtualization is done because single physical server can be divided into multiple servers on the demand basis and balancing the load. Why we need to do the server virtualization? We are doing the server virtualization so that we can divide a single physical server into multiple parts, into multiple servers, so they can handle the multiple requests. So there will be no any type of deadlock and the load is balanced. properly. That's why we need to go for a server virtualization. It means virtually we are dividing the server into multiple parts, means we are dividing single physical server virtually into multiple servers, so the load balancing should be done properly. The last category of virtualization is storage virtualization. Storage virtualization is the process of grouping the physical storage from multiple network storage devices so that it looks like a single storage device. So in this case, we have to group physical storage from multiple networking storage devices. It may be a pen drive, floppy disk, hard disk, so that they all look like a single storage device. So storage virtualization is also implemented by using software applications. Its uses is that it is mainly done for backup and recovery purpose. So we know that we have to keep the backup and recovery. So storage virtualization means we get the storage, we get the physical storage from multiple network storage devices and make the group of it so that they look like a single storage device. We need to do the storage virtualization because we want to do it for a backup and recovery purpose only. Next is, how does virtualization work in cloud computing? Now the question is that how can we achieve virtualization in cloud computing? So virtualization play a very important role in a cloud computing technology. Normally in a cloud computing, users share the data present in the cloud like applications, but actually with the help of virtualization, users share the infrastructure. So if we are using virtualization in a cloud computing, user can share the applications, but also they are able to share the infrastructure. The main use of virtualization technology is to provide the applications with standard versions to their cloud users. Suppose if the next version of that application is released, then cloud provider has to provide the latest version to their cloud users, and practically it is possible because it is more expensive. So the thing is that, let us suppose I have purchased a cloud from the cloud service provider. I pay the money, get the space over the internet. Day by day, the technology is going to be changed. It's not possible for the cloud service provider to give me a latest version of technology because it's expensive one. So we have a solution for this problem. To overcome this problem, we go for a virtualization technology. By using virtualization, all the servers and software applications which are required by other cloud providers are maintained by third-party people, and the cloud provider has to pay the money on monthly or annual basis. This problem can be handled by using the concept of virtualization. When everything is virtualized and all the servers, all the software applications that we are using is completely controlled by a third party, we just need to pay the money and we get the virtualization facility in our clouds. See the diagram. We have application. vCenter means virtual center. Application management, we have our infrastructure management. So we can virtually access application management and infrastructure management. Here we have a .NET, software as a service, Windows, Linux, J2EE, desktop or app. This is the VMware infrastructure, which is virtual data center operating system. It's a virtual data center operating system from VMware. So application services are availability. It should be available. Security, it should be secure enough. Scalability, it should be scalable enough so that we can add more services according to the requirement. And its infrastructure services are, we can virtually compute it, store on it virtually. V stands for virtually. Network means we can do the networking among the devices. We have some cloud services. Now we have a two type of cloud services. On-premises cloud means we can get the cloud on demand. Next is off-premise cloud. We can get the cloud whenever we need it. So this is the VMware infrastructure, means it's a virtual data center operating system which is supported by VMware. We have a different types of features. It has application services, it has a infrastructure services. Now see the benefits of virtualization. First, it is more flexible and efficient allocation of resources. If we are going for virtualization, or if we are using virtualization, we can divide the workload very easily. If, let us pose an example, we are working on a one or a single physical server, and we have three transactions or three requests that are waiting or that want to access this physical server, but I have only one physical server and three transactions are waiting for it. It is not possible to give a single physical server to three transactions at the same time, but we have to handle this. We can handle this problem by using the concept of virtualization. So that your task is to divide the physical server virtually into three parts so that the load can be balanced very easily. Next is it enhance the development productivity. Definitely, if we are balancing the load in a very efficient manner, your development productivity will be enhanced. It lowers the cost of IT infrastructure. Let us suppose that for three requests, if I'm working on a physical server, I have to purchase three servers. But if we go for the topic of virtualization, this can be handled very easily. I have to split, I have to divide the single physical server into virtually into three categories, and load should be balanced easily. Remote access and rapid scalability. We can access the resources anywhere over the cloud because we are implementing the virtualization on the cloud. So cloud means over the internet, we can access the data remotely, and rapid scalability means we can access it anywhere, and it should be scalable enough, it should be capable enough to add more services. High availability and disaster recovery. So it should be available 24 into 7 hours. Disaster recovery, if any type of problem arises, we can recover it. Pay per use of IT infrastructure on demand. As we have already discussed in our previous cloud computing classes, we have to pay to the cloud service provider, and we have to pay to the vendor and get the cloud according to the requirement or according to our demands. Enable running multiple operating system. If we are implementing virtualization, we are capable enough, we are enabled to run the multiple operating systems, or on multiple operating systems we can run different applications. So these are the benefits of implementing or using virtualization in cloud computing. Next term we have, that is called hypervisor. As we have studied in the previous slide, hypervisor control, manage the processors, the hardware resources, the network resources, the memory. So hypervisor is a form of virtualization software. So hypervisor is what? It is a virtualization software that is used in cloud hosting so that it can divide and allocate the resources on various pieces of hardware. So hypervisor is a virtualization software that we simply use so that we can divide and allocate the resources on the various or on the different pieces of hardware. The program which provide partitioning means dividing, isolation or abstraction is called a virtualization hypervisor. So it's a program that provide you partitioning, means that that is dividing your hardware into smaller pieces, that provide isolation, hiding your hardware from a external, or abstraction. Abstraction means getting only the essential details without going into the difficulties. That is called virtualization hypervisor. Hypervisor is the hardware virtualization technique that allow multiple guest. We are talking about multiple guest operating system, and we studied in the previous slide, virtual machine is also known as a guest machine. So hypervisor is the hardware virtualization technique that allow multiple virtual machines to run on a single host system at a same time. A hypervisor is also known as a virtual machine manager. So hypervisor is the form of, it's a virtualization software. Basically, its task is to divide and allocate resources on the different pieces of hardware. It's a program that provides you partitioning, isolation, and abstraction. And this type of hypervisor is called a virtual machine managers, or its task is to, it can allow multiple virtual machines to be run on a single system at a same time. If we have a single physical server, we can run only one operating system on it. But with the help of virtualization, we can run multiple guest operating system on single host system at a same time. So this is the working of hypervisor. Next, we have types of hypervisor. Type 1 hypervisor and type 2 hypervisor. Now we are going to discuss firstly for a type 1 hypervisor. The hypervisor that runs directly on the host system comes under the category of type 1 hypervisor. It's also known as a native hypervisor or bare metal hypervisor. It does not require any base server operating system. It has direct access to hardware resources. So type 1 hypervisor means that is running directly on the host system. It's also known as native hypervisor or a bare metal hypervisor. And it does not need any type of base server operating system for running. It can directly access the hardware resources. Example of type 1 hypervisor include Vmware Esxi, Citrix Exen Server, Microsoft hypervisors. We have some benefits and drawbacks of type 1 hypervisor. First is that such kind of hypervisor are very efficient. This is the advantage of using the type 1 hypervisor. Such type of hypervisor are very efficient because they have direct access to the physical hardware resources. And this caused the empowerment, the security, because there is nothing, any kind of the third party resources, so that attacker could not compromise with anything. The main advantage of using type 1 hypervisor is that it can directly access to the hardware components, like it is directly connected with CPU, directly connected with memory, directly connected with network, physical storage. So there is no any involvement of third party, so it is more secure. We cannot, we don't have any type of risk so that it can be hacked by any hacker. It's much secure because hypervisor can directly communicate with soft hardware resources. Now see, one of the problem with the type 1 hypervisor is that they usually need a dedicated separate machine to perform its operations and to instruct different virtual machines and control to the host hardware resources. The main problem is that if we want to run the type 1 hypervisor, we need a separate machine. We need a separate host system where we can only run or implement the type 1 hypervisors. So type 1 hypervisor means it is the one type of hypervisor that directly running on the host system. It is it's also known as a native or bare metal hypervisor, and it can directly interact with hardware resources, so there is no third party requirements. So it assumed to be more secure as compared to other type of hypervisor. But it has one problem. Whenever we want to go for a type 1 hypervisor, we just need a separate machine where we can run its operations. And we need a separate machine if we want to instruct different virtual machines how to, and we just want to control the host hardware resources. This is one of the drawback of using type 1 hypervisor. Second is type 2 hypervisor, a host operating system run on underlying host system. It is also known as hosted hypervisor. One host operating system is running on other host system, and type 2 hypervisor is also known as hosted hypervisor. Such type of hypervisor not directly run on the hardware, but they run on the applications in the host system. It means it is different from type 1 hypervisor, because we have seen in a type 1 hypervisor, it is directly running on the host machine. It can directly access the hardware resources. But the type 2 hypervisor is different from type 1 hypervisor, because in a type 2 hypervisor, it is running on one host machine that is completely dependent upon other host machine. That's why it's known as hosted hypervisor. And this type of hypervisor is does not directly running over the hardware, because they are running on the applications that is depend upon some other physical machines. Software installed on operating systems. Hypervisor asks the operating system to make hardware calls. If we want to implement this type of hypervisor, first it asks to the operating system to make hardware call. Example of type 2 hypervisor include VMware Player or Parallel Desktop. These two are the example of type 2 hypervisor. Example of type 2 hypervisor include VMware Player or Parallel Desktops. Hosted hypervisor or type 2 hypervisor often found on endpoints, like it is mostly available in PCs, personal computer. The type 2 hypervisor is very useful for engineers for security analysis. So this is one type of the hypervisor that don't directly run on the computer hardware, that don't access the computer hardware resources. They run on the host system, and it is known as hosted hypervisor. Basically, such type of hypervisor is used when we want to work for engineering, or we just want to go for security analysis. It has some advantages and disadvantages. First, go for advantage. Such kind of hypervisor allow quick and easy access to the guest operating system alongside the host machine running. So because we know that it example is parallel desktop. Parallel means more than one instructions or transactions are executing at the same time. So such kind of hypervisor allows quick and easy access to the guest operating system alongside the host machine running. So we can even access the guest operating system, or on the same time we are running a host machine. These hypervisor come with additional useful feature, like it has some features for guest machine. Such type of tools enhance the coordination between host machine and guest machine. So it's capable enough to handle both machines at a same time. It can manage the host machine, and parallelly on the same type it can manage the guest machine. So it can manage both machines at a same type, host machine and guest machine. Next, we have some disadvantages of using the type 2 hypervisor. Here there is no direct access to the physical hardware resources, so efficiency of these hypervisor lags in performance as compared to type 1, and security risk is very important factor in this case, because we are not directly interacting, and such type of machine is not directly interacting with hardware resources. So there is a chances of risk. So there is a chances of data loss. So there will be chances of attacker. So this is some of the advantages and disadvantages of using the type 2 hypervisor. Next, we have a virtualization hypervisor technologies. Next, we have some type of hypervisor technologies, and the first one is Exxon. This is one of the hypervisor technology that we have to use. Exxon is an open source. If these are the hypervisor, we can say it as a types or a technologies of hypervisor. First is Exxon. Exxon is an open source hypervisor. Basically, it's a hypervisor. Its task is to control and manage the processor, memory, and network resources. It is an open source hypervisor that is based on the para virtualization. It is most popular application of the para virtualization. Exxon has been extended to compatible with full virtualization using the hardware assisted virtualization. It is one of the type of the hypervisor that is completely based on para virtualization. It is, and its most popular application of para virtualization. It is achieving full virtualization. How? Because it's completely using the hardware assisted virtualization. It provides full virtualization. It enables high performance to execute guest operating system. We can run the virtual machine with high performance. This is done by removing the performance loss while executing the instruction requiring significant handling, and by modifying the portion of the guest operating system executed by Exxon with reference to the execution of such instruction. This hence this especially support x86 which is the most used architecture on commodity machines and server. So this is one of the type of the hypervisor. Basically, this type of hypervisor is used when we want to achieve a full virtualization. And if we are running or executing the guest operating system, it provides high-end performance. And this is done by removing the performance loss, because we have to remove the parts of memory or anything that is creating the problem. And this type of hypervisor is supporting the 86 architecture, which is most common architecture that is used on commodity machines and servers. This is the architecture, Exen architecture and guest operating system management. We have a 3 types of rings in this. We have a 3 types of rings in. This is the diagram of Exen architecture. We have ring 0, 1, 2, 3. Every ring have a different task. Ring 0 have Exen hypervisor, that is called virtual machine manager. It is controlling the memory management, CPU state registers, device input output. And this is also bidirectionally communicating with hardware 86. This is the architecture x86. All are interacting with each other bidirectionally. And ring 1, it has management domains like virtual machine management, hypertext transfer, protocol interface, access to Exen hypervisor. Next, again, ring 1 have a user domains, guest operating system, modified code base, hypercalls into Exen, virtual machine manager. Next, ring 3, this is for user applications, unmodified API. So this is the architecture of Exen architecture. This looks like a spiral and it has 3 rings. Every ring have a different working. Basically, it is a hypervisor, and we know that hypervisor is basically used to control the processors, to manage the memory, and to control the resources. Above figure describe the Exen architecture and its mapping onto the classic x86 privileged model. An Exen based system is handled by Exen hypervisor. If we are using the Exen based system, then it should completely handled by Exen hypervisor, which is executed in the most privileged mode and maintains the access of guest operating system to the basic hardware. Guest operating system are run between domains which represent virtual machine instance. Basically, if we are working on an Exen based system, then we have to make it sure that it should be handled by the Exen hypervisor, because this hypervisor manages the processors, memories, and other components. In addition, particular control softwares which has privileged access to the host and handles all other guest operating system run in the special domain called domain 0. So let us suppose that we have some other control softwares. We have some that softwares are accessing the host and these softwares are handling the guest operating system. They all are running on a one special domain that is called domain 0. This is the only one loaded once the virtual machine manager has fully booted and host an HTTP server that delivers the request for virtual machine. So this is only one loaded. Once it is loaded, the virtual machine manager is now fully booted and the host, that is HTTP server, it delivers the request for virtual machine creation, for virtual machine configuration, and for virtual machine termination. And this is one of the component that establish the primary version of virtual machine manager, which is the necessary part of cloud computing system delivery, especially for infrastructure as a service. So we have some particular control softwares. So, and these softwares are accessing the host and some of the guest operating system. They need to be run on a special domain that is called domain 0. You just need to load it. Once it is loaded, virtual machine fully booted, and we have a host that is HTTP server. It delivers the request for all the virtual machine, either creation, configuration, and termination. And this is one of the component that is the necessary part of cloud computing. Infrastructure as a service. Various x6 implementations support 4 different security levels, which is known as rings: ring 0, ring 1, ring 2, and ring 3. Ring 0 represent the level having most privilege. So ring 0 representing the level having most privilege means most rights, accesses. Whereas ring 3 represent the level having least. So ring 3 representing the level has a very less privileges. It has only user applications. It has Exen. Ring 0 has Exen hypervisor, memory management, CPU state registers, devices input output. Almost all the frequently used operating system except operating system by 2 uses only 2 levels: 0 for kernel code and ring 3 for user applications and non-privileged operating system program. Basically, these 2 rings are commonly used, 0 for kernel code and third for user application. This provides a chance to the Exen to implement para-virtualization. So this enable Exen to control unchanged the application binary interface, ABI, application binary interface. So user application have unmodified means not changeable ABI. ABI stands for application binary interface. So it has unmodified ABI, application binary interface, thus allowing simple shift to Exen virtualized solution from application perspective. So here we have 4 types of rings: ring 0, 1, 2, 3, 4, and most highly privileged ring is 0 and least privileged ring is ring 3, 0 for kernel code and 3 for user applications. We have ABI, that is called application binary interface, and it is under the user application area. Due to structure of x86 instruction set, some instructions allow code execution in ring 3 to switch to ring 0. So it's depend upon the architecture. Some of the instructions allow code execution from ring 3, then switch to ring 0. It can be switched from 3 to 0, and we know that 3 to 0 means from user applications to kernel code. Such an operation is done at the hardware level. So this switching means ring 3 at a user level application, and ring 0 is for kernel mode, means we are switching it from user application to kernel mode. Such operation is done at a hardware level, and hence between a virtualized environment, it will lead to trap or silent fault. So trap is one of the type of fault that occurs, and this is also known as a silent fault, thus preventing the general operation of guest operating system as it is now running in a ring 1. So it's depend upon the architecture. Some people want to switch from ring 3 to ring 0, and all these operations will be implemented on the hardware level. So if we are working in a virtualized environment, there will be a chances of trap or silent fault that will basically prevent the guest machines to be switched from ring 3 to ring 1. And this type of condition basically occur by the subset of system calls. In the normal life, if I want to communicate with all of you, I just want to call you people either by your name, by your roll number. In the same way, the computer can communicate with each other by using the system calls. To eliminate this situation, implementation in operating system require a modification, and all the sensitive system call need re-implementation with hypercalls. So if you want to overcome this problem, you want to solve this problem, you just need to modify all the sensitive system calls. Once it is modified, we need to re-implement it with hypercalls. Hypercalls are the basically types of calls that is revealed by virtual machine interface of Exen and by use of it. So hypercalls is such type of calls that should be revealed by virtual machine interface of Exen. Exen hypervisor tend to catch the execution of all sensitive instructions. It is responsible for the smooth execution of sensitive instructions, manage them properly, basically return the control to the guest operating system with the help of supplied handler. So this is the working of Exen architecture. Para-virtualization demands the operating system code base be changed, and hence all the operating system cannot be referred to the guest operating system in the Exen based environment. Once the code is changed, now it's not easiest for all the all the operating system to be accessed the guest operating system that is running in the Exen based environment. This condition hold where the hardware assisted virtualization cannot be free, and this is only possible if you are using the licensed virtualization. It is not possible if you are where the cannot be free, and this is only possible for those situations where you are paying money. It is not for only those situations where it is free, which enables to run the hypervisor in ring 1 and guest operating system in ring 0. Exen shows some limitations in the terms of latency hardware and in the terms of operating system. So basically the thing is that we have to change the operating system code base. Once it is changed, so that why it is need to be changed, so that all the operating system cannot access the guest operating system that we are executing on the Exen based environment. And this is only possible if we're working on a paid, not on a licensed. In fact, these are not possible to modify to be run in the ring 1 safely, as their code base is not reachable, and concurrently the primary hardware has not any support to execute them in the more privileged mode than ring 0. Now, there is another problem. If we want to modify the code that is running in the ring 1, because now we have already discussed, if we change the code base, such guest operating system is not accessible by all other operating systems, so it will be problematic because we don't have a hardware that's to execute the instructions or applications in the ring 0. Open source operating system like Linux, they can be easily modified because their code is openly available to everywhere. We know that Linux is open source, and we know what open source means: easily available on the internet, and anybody can install it, download it, and change it code. Exen deliver full support to virtualization, while components of Windows are basically not compatible with Exen. We know that Exen is for full virtualization, but its components are not feasible with all the components of Windows is not sometimes feasible with Exen architecture. If you have a hardware assisted virtualization, then Exen can be compatible with Windows, as new release of operating system are designed to be virtualized. Now, in a coming days, the operating system are comfortable and friendly with virtualization. It has some advantages. First is Exen server is developed over open source Exen hypervisor, and it uses a combination of hardware virtualization and para virtualization. So this is tightly coupled collaboration between operating system and virtualized platform enables the system to develop lighter and flexible hypervisor that delivers their functionality in an optimized manner. So basically it's open source. Exen server is depend upon an open source Exen hypervisor. So that hypervisor is the combination of hardware based virtualization and para virtualization. So it's good enough because it's a flexible hypervisor that give functionalities or deliver some functionality in a very good manner. B is that Exen support balancing of large workload efficiently that captures CPU, memory, disk I/O, and network I/O of data. It offers two modes to handle the workload: performance enhancement and for handling the data density. So in Exen architecture, we can easily balance the load. We can balance the CPU, memory, data I/O, network I/O. It offers two modes to handle workload. First one is performance enhancement, means how can we improve or enhance the performance, or how can we handle the data density, means depth or level of the data. It is designed with some special storage feature like we can call Citrix storage link, which allows system administrator to use the feature of arrays. So it is designed with some of the good storage features because it follow Citrix storage link, and that link have some characteristics features of array because it is supported by HP, NetApp, Dell EqualLogic. It also supports multiple processors. We can go for a multiple processors. We can migrate from one machine to another live in a live mode, physical server to virtual machine, virtual to virtual machine conversion tool, We have a centralized multi-server management, real-time performance monitoring over Windows and Linux. So these are some of the advantages of using the Exxon architecture. It has some disadvantages, more reliable over Linux than on Windows. It is only comfortable with Linux, not with Windows. It completely depends upon third-party components for drivers, for storage, for backup, for recovery, for fault tolerance. We need to depend, or we are completely depend upon third party. We don't have a direct interaction. Extend deployment could be burdensome on your Linux kernel system as time passes. So as the time is going on, it's not so much comfortable with Linux. Sometimes it increases the load on your resources by high input output rate and may cause starvation of other virtual machines. So sometimes it increases the load on your resources if it requests for a high input output rate, and sometimes it will create the problem of starvation for other virtual machines. Starvation means some virtual machine don't have any resources, they are on the stage of starvation. Next type of hypervisor that we have is VMware. VMware is an American cloud computing and virtualization technology company that is headquartered in California, and it was first successful company to virtualize the x86 architecture. So basically it is one of the company that is located in California, and this is the company who first tested the virtualization on a x86 architecture. VMware desktop software runs on Microsoft Windows, it can run on a Linux, it can also run on a Mac operating system, while its enterprise software hypervisors for servers. Vmware Esxi is a bare metal hypervisor that runs directly on the server hardware without requiring additional underlying operating system. So VMware is one of the company that is supporting the virtualization, on a x86 architecture. Basically, it's a VMware desktop software can run on any operating system like Windows, Linux, Mac operating system. So such type of hypervisors run directly on the server hardware. It does not require any other type of operating system because it directly run on the hardware. So desktop softwares. VM Workstation that is introduced in 1999 was the first product launched by VMware, and this software suite allows user to run multiple instances of x86 or x86-64 compatible operating system on single physical personal computer. Workstation Pro version 15.5.1 was released in November 2019. So first of the desktop software that is supported by VM Workstation is introduced in 1999. It can support both x86 or x86-64 operating system, and these operating systems can easily run on single physical personal computers. VMware Fusion provides functionality for users of the Intel Mac platform along with full compatibility with virtual machines created by other VM products. So we can use any type of VMware product. VM Workstation Player is freeware for non-commercial user without requiring a license. We can access the VMware Workstation Player. We don't need to pay the money for it. But it is free for only a non-commercial users. We don't need any type of license, and it is available for commercial use with permissions. For commercial use, you have to get the permissions. For non-commercial use, you don't need to go for permissions or need to get the license. And this is similar with the VM Workstation, but it has some less functionalities. Networking and security products. These are the products of VMware. VMware NSX is a VMware network virtualization product that is marketed using the term software defined data center. SDDC stands for software defined data center, and it is the virtualization product. The technology included some acquired from 2012 purchased of Nicira. So networking and security product is one of the product that is supported by VMware. It has Cloud management softwares. VMware vRealize Suite. It is the cloud management platform purpose developed for hybrid computing cloud. We know that we have a public cloud, private cloud, community cloud, and hybrid cloud. That is the combination of public cloud and private cloud. VMware Go. It is the web-based service that guides the user of any level through the installation and configuration of VMware vSphere Hypervisor. It is one of the web-based services. VMware Cloud Foundation. It is the cloud foundation that provides an easy way to deploy and operate a private cloud on any SDDC. SDDC stands for Software Defined Data Centers. It is for a private cloud. Last is VMware Horizon View is a virtual desktop infrastructure product. So these are some of the cloud management software that is supported by VMware. Server software. VMware Esxi is one of the software products that can deliver greater performance than freeware VMware server due to lower system computational overhead. VMware Esxi, as it is known as bare metal product, it directly run on the server hardware. So it allows virtual servers to use hardware more or less directly because it's directly working on the hardware. So it's up to this, it want to use the hardware in a less manner or it want to use the hardware in a more manner. In addition, VMware Esxi integration into VMware vCenter, which offers extra services. So it integrates with VMware vCenter, so it give more double functionality. Application management. The VMware Workspace portal was a self-service app store for workspace management. So application management means we have a VMware Workspace portal that is a self-service app that we can store or install for workspace management. Then it has storage and availability. VMware storage and availability products are composed of two primary offerings. It has VMware vSAN, VMware Site Recovery Manager. VMware vSAN means VMware Virtual SAN is a software that is defined storage solution and it is embedded in or imposed in VMware Esxi hypervisors. The vSphere and vSAN software, they run on a x86 architecture, and network operators that need to have a servers from HCL hardware compatibility list to put onto production. The first release of this version is version 5.5, released in 2014, and the next 6th generation we get this version in a 2017. Next, we have a VMware Site Recovery Manager, that is called SRM. Site, S stands for site, R stands for recovery, M stands for manager, is the disaster recovery solution that automates the failover and failback of virtual machines to and from a secondary site using policy-based management. It means if a virtual machine get failed and get some problems, obstacles or failure, error, then this is one of the recovery solution that automatically take the failover and take the failback of virtual machines. Next, we have Hyper-V. It is also one of the hypervisor technology, virtualization technology or platform, commonly known as a hypervisor. We have a different types of hypervisor in the market. Hyper-V is the Microsoft version. Some others that are well known are VMware Esxi, we have a vSphere, we have a Exen server, we have a KMV open source hypervisor, we have a RHEV that is called Red Hat Enterprise Virtualization. But in today's this class or in this lecture, we are going to discuss about Hyper-V. See, we have a parent partition and child partition. In parent, we have a VMI providers, virtual machine management services. This is the virtual machine worker processes. This is, we are talking about parent partition. Windows kernel, virtualization service provider, that is called VSP, device drivers, virtual machine bus, and we hypervisor, and that is the ring 1, and the last is hardware. On the child partition, we have applications that is in a user mode. We know that ring 3 is for a user mode. On ring 0 kernel mode, we have a virtualization service consumer. In this, we have a virtualization service provider. In child partition, we have a virtualization server consumer. Here, window kernel, same we have a window kernel and virtual machine bus. This is how the hypervisor we work. Hyper-V terminology, we have a host machine, Hyper-V virtual hard disk, guest virtual machine, virtual network, virtual hard disk or virtual switch. First, host machine. The physical computer that provides resources that may be including processing powers, memory, disk uses for your virtual machine. So host machine is one of the computer or physical computer that is giving the resources including processing power, it include memory, it include disk uses for your virtual machines. Next, we have a Hyper-V virtual hard disk. Microsoft virtual hard disk format. It is next generation VHD. Basically, VHDX file have 64 TB capacity. Advantage of VHDX are not limited to improved capacity. VHDX files were designed to work with today modern hardwares and have 4 KB logical sector size that improve performance compared to VHD files. So Hyper-V virtual hard disk means it is one of the hard disk for storage capacity and it has a 64 TB data capacity. Next, guest virtual machine. Host virtual machine is a service provider. See the difference? Host virtual machine is a physical computer that providing the resources. It's just like a server. We know the term client and server. Client is the computer machine that is sending the request, whereas server is the computer system that is handling the request sent by the client, process it and give the result back to the client. So host machine is the physical machine which is processing the request sent by the client. It provides the various resources, whereas guest machine, it is virtual operating system and application softwares that run on host machine, and it is using the resources of host machine. It means, let us suppose host machine assumes to be like a server machine and guest machine which is running on the server, not running independently. Guest machine is a machine that is running on a host machine, accessing the resources of host machine. Virtual network that connect virtual machines and host machines together, and so that they can interact with each other, they can share resources, but everything should be done virtually. Virtual hard disk, a file format disk that is used for any type of data storage. We can store large files into virtual hard disk. Virtual switch, it allows virtual machines to be communicate with one another. Because it's a virtual switch, they are intelligent, meaning they inspect the data packets before routing communication. Virtual switch is switch, we know that it is the networking device like a router, bridge. Switch is for networking, so they can easily inspect or check the packets before the routing communication. Virtual machine monitor, it is the tool that monitor your virtual resources. Either this machine is working correctly, all should be handled by virtual machine monitors. Checkpoint preserve the state of virtual hard disk and all of its contents, including application files, a specific point in the time. The virtual machine can be reverted back to the checkpoint state. Let us suppose that we are working on a virtual machine. So we have to set the checkpoint where this machine got corrupted or should be dumped or should be fall into any type of error or fault, so that we can recover from this checkpoint. Basically, it is used for recovery and backup. Virtual machine template, it is the master copy of virtual machine that is used to be created with the new virtual machine with same characteristics. It means we are working on one virtual machine. If we have a virtual machine template, we can design a new virtual machine with same capability and functionality. Hardware requirement for Hyper-V hardware requirement. We need a 64-bit processor with second level address translation, SLAT. Basically, SLAT is the technology Hyper-V uses. Whenever it asks to retrieve the data on instruction, it is essentially translate the virtual address into physical addresses. So which save money and which save memory and reduce the CPU time. So some information on how to check whether your Intel or AMD processor supports SLAT. So first you need 64-bit processor. Second, you need SLT. SLAT is a second level address translation. It is clear from name, it is address translator. It converts the virtual address into physical address. VM monitor mode extensions. So we need a VM monitor mode extensions. We need at least 4 GB of RAM. We need virtualization support turned on in BIOS basic input output or UEFI, Unified Extensible Firmware Interface. These are some of the hardware requirements for Hyper-V. Benefits. The capability to create a virtual switch come at no extra cost. Virtual switch allow all of your virtual machines to communicate with each other, making it as an integral part of virtual networking. So virtual switches enable your virtual machines to be communicate with some other virtual machines, and virtual switches are intelligent, means they can check the data before put it into the router. The capability to configure traffic in this way improves security within your virtual environment. So it has capability to so that your virtual machines can communicate with each other. So we do not need to pay extra charge for it. Hyper-V support multiple operating system. It support multiple operating system like Linux, Unix, Windows. If we are using multiple operating system, it means we can run different applications on different operating system. It simplifies live migration. This Hyper-V feature allow you to move running VM from one Hyper-V host to another without downtime. So we can easily do the migration. We can move the virtual machine from one Hyper-V host to other Hyper-V host. Live migration are simple, and it promotes continuous operation of your network. So these are some of the advantages of using Hyper-V Hypervisor. Thank you so much, class.